episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Okay, welcome everybody again to another episode with another fascinating guest who is really involved in creating an amazing tomorrow for all of us. To start with a little background though, have you ever found yourself sitting in a movie theater, in a sci-fi movie, and you find yourself drifting away from the plot of the film? And for about 20 minutes or so, instead, you find yourself focused on a particular space station or lunar base or some other futuristic technology. And you start asking yourself, how do they do that? Who designs this stuff and how do they get it out there? They never show sort of that transition from the present to the sci-fi future. Well, in the real world, it's people like our guest today who are responsible for turning all the science fiction into reality and science fact. We're honored today to be joined by Melodie Yashar, designer, researcher, technologist, co-founder of the firm Space Exploration Architecture, Senior Research Associate with San Jose State University Research Foundation at the NASA Ames Research Center, and an Associate Researcher within the UC Davis Center for Human Robotics and Vehicle Integration and Performance. She also teaches undergraduate and graduate design at the Art Center College of Design and is a 2019-2020 Future Space Leaders Fellow. Melodie's current work focuses on the relationship of advanced software and hardware systems for spaceflight, and she maintains ongoing research interest in the design of augmented environments, human-machine interaction, human performance studies, and space technology development. As an undergraduate, Melodie studied at UC Berkeley and at Art Center, and she holds graduate degrees in architecture and human-computer interaction with an emphasis in robotics from Columbia University and Carnegie Mellon University, respectively. She also served as visiting professor at Pratt Institute, as a researcher within Carnegie Mellon's Morphin Matter Lab, and the science director of Sonic Platforms. And having come from a rather diverse interdisciplinary background, Melodie has a wide appreciation for those who see research and design as a confluence of different fields, allowing for problem solving to become a much more collaborative exercise. Melodie, thank you for taking the time out of your schedule to come on the show today.
Thank you so much, and thank you for the great and thorough introduction. I appreciate it.
My pleasure. My pleasure. I'm really excited about this. There's a lot of shit, but this one I'm extremely excited about just because I love sci-fi and I love space, and I'm just really amazed by everything you're involved in. I'd like to start off as we normally do. We hand the guest the floor for really as long as they want. So if you could sort of just go a little bit into who you are, take us back a little bit, so where you grew up, how you developed this rather sort of wide-ranging, convergent knowledge base in all these varying subjects, and a little bit of how you got to what you're doing today. I think that'd be a great way to start things off.
Sure. Yeah, definitely. So I'll tell you a little bit about the origins of Search Plus and how that group started and how we incorporated and how we began doing all of this work for basically conceiving of concepts and habitats for living in space. Really, none of us expected to be where we are today. The core group of individuals that formed Search Plus, most of us had met in graduate school or after graduate school at Columbia University School of Architecture, where there was a space studio that we had all participated or been associated with. We came together as a group to submit to NASA's Phase 1 Centennial Challenge for a 3D printed habitat on Mars. We were just a loose group of individuals. We were working nights and weekends, put together a proposal with a group called Clouds AO called Mars Ice House. And a huge surprise to us, we won first place, beating Foster and Partners, which is a huge international architecture firm, as well as the European Space Agency. So we were absolutely the underdogs at the time. And that first win within the Phase 1 challenge in 2015 really was a life-changing moment. when we won the challenge, we incorporated a Search Plus as an LLC, and slowly but surely we started to get attention from aerospace companies and from other individuals and principal investigators, scientists, and researchers at NASA who were interested in what we were doing, interested in the approach that we were taking to introducing human supporting design concepts for living in space and for space exploration. And things slowly evolved from there. Again, it was not something that any of us had really planned. It happened very organically. Shortly after we won the phase 1 challenge, we were very fortunately and very fortuitously connected with a principal investigator at NASA Langley. We created a spin-off project from the Mars Ice House, which became known as the Mars Ice Home. And another spin-off project, or I guess you could say an offshoot of the work that we had done from the phase 1 challenge, we began working as a consultant for United Technologies Aerospace Systems, which is now Collins Aerospace. We came up with we went through a design charrette process where we sort of encouraged them to adopt a human-centered approach to the way that they were designing their ECLSS hardware. ECLSS is environmental control and life support systems, and that was a extended collaboration where we were working together to figure out what is a human supporting concept for how this hardware can integrate within a larger vehicle, such as like a Mars transit vehicle. This was part of the Next Step program with NASA. Another project after the phase 1 competition that we worked on was the NASA Big Ideas Challenge. So we an offshoot project of the Mars Ice Home became the Big Ideas Challenge in collaboration with NASA Langley, where we came up with a competition together and organized a competition where we were soliciting concepts for Mars greenhouses. So using the infrastructure of the Mars Ice Home, using the resources and we like to say ISRU, which is in situ resource utilization, hardware and technologies that would be there on the surface of Mars, to come up with a concept of operations for a Mars greenhouse. That was a very successful competition, which led to a number of internships and a number of continued, I guess you could say, research projects at NASA Langley for that concept to move forwards, including material studies, which for an inflatable pressurized membrane for the habitat. What happened, an interesting kind of story after the phase 1 competition was that even though the Mars Ice House had won first place unanimously among all of the judges within the first 3D printed habitat competition, which was exclusively a design competition, there was so much internal resistance to the concept of an ice house being the concept that would actually move forward to develop technology solutions in-house at NASA, because the standard and kind of expected approach to developing 3D printed houses in outer space would be to use regolith, which is the dirt that's there on the surface of the moon and on the surface of Mars. It's readily available. You don't have to do any kind of subsurface mining or excavating. It's an obvious choice for 3D printing, and it kind of aligns very well with large-scale terrestrial 3D printing that happens in concrete, for example. So what happened is that the NASA Centennial Challenge program reinstated the competition within phase 2 and phase 3 with an express rule that water should not be included as a building construction material. Us being enthusiasts and us being sort of committed and passionate about the cause and the idea of conceiving of these habitat designs, we also submitted to the phase 3, not the phase 2, but the phase 3 competition. And so a big surprise to us was that we ended up winning first prize in final design in that phase of the competition as well. So we're the only team to have won both design solicitations for 3D printed habitats from NASA Centennial Challenges. The concept for the phase 3 habitat was a sulfur concrete regolith printed shell. with a high density polyethylene, which is basically a polymer plastic inner layer that would be 3D printed on the surface of Mars. Each one of these habitat concepts that we've worked on have always assumed a crew of 4 would be on the surface of Mars for 1 year. And so we provide consumables, and we do the appropriate space planning and programming based off of those parameters. And very fortunately for us, we were able to work with a group called Apis Core at the Autodesk build space in Boston to do some construction prototyping for 3D printing. At the time, that was in concrete, and we were able to win first prize in the construction levels of the competition, construction levels 1 and construction levels 2. So that was the extent of our work in the 3D printed habitat challenge from 2015 up until 2019. Certainly as a passion project, and no one is ever paid to submit or work on these competitions unless, of course, you win, and there is a prize purse that comes with winning. So it's a challenging thing, but it certainly has been a launch pad and a kind of accelerator for my career as well as the careers of others in Search Plus. Most recently, we recently finished a collaboration with Icon 3D, which is a startup based in Austin, Texas, who is developing life-size 3D printed residential and housing prototypes in collaboration with NASA Marshall Space Flight Center. And together we're basically collaborating on what's known as the MPACT initiative. NASA loves acronyms. So MPACT stands for Moon to Mars Planetary Autonomous Construction Technologies.
Okay.
So the idea is that together with Search, as well as Bjarke Ingels Group as the design partners, and Icon as the hardware and technology developers, and with NASA Marshall leading the way as a kind of, I guess you could say, orchestrator for all of these activities, the idea here is to deploy the first 3D printer additive manufacturing system on the moon by 2028, and to start off by building surface infrastructure, so landing pads, roadways, berms, blast walls, and basic civic infrastructure that you can imagine for an initial moon base, and eventually use that same construction system, that same construction technology to 3D print pressurized habitats for a long-term permanent settlement on the moon. So this is our current work. This is what we are striving for, and yeah, I guess I'll leave it at that as my introduction.
Wonderful, wonderful. It's so exciting to to hear all this, and coming back to your bio where you talk about sort of the confluence of all these different fields. Obviously, when I'm reading through your website and looking at some of these specs for things like the Ice House and the X House and so forth, you have such a diverse range of concepts, things you have to bring to the table. You have to obviously deal with, keeping a Mars entity or astronaut alive in the house. Of course, they need to be able to breathe. You need to shield them from radiation. At the same time, you need to provide them water. They have to grow food. So many different disciplines. Talk about sort of when you sit down to do this at first and say, okay, we got to build this house which keeps people alive and feeds them and make sure they don't die in a year from the radiation. How does that all work together? What's involved in all that? It's really neat just thinking about you bringing these different conversion capabilities together.
No, yeah, it's challenging to say the least, but it's not like we come to the table knowing all the answers. Sure. And what I've realized in doing this work is that this is such a wicked problem. There really isn't one answer or one way of approaching this. Oh, sorry. Can you hear me? I think I might have cut out for a second.
No, I can hear you fine.
Oh, okay, good.
Yeah, you're fine.
Green for us. I was concerned. It's such a wicked problem that there isn't one answer. There isn't one way of doing things, and every approach is going to is representative of a certain value system, right? So if your value system is to protect the astronauts against radiation, there might be a trade-off that needs to be made for some other parameter that you're working with. But essentially, it is a learning process, and I'm continuing to learn and collaborate and work with others who are at the cutting edge of research, who are at the cutting edge of what the state of the art is relative to the technologies that not only keep people alive in outer space, but construction technologies more generally. I certainly, one person does not have all the answers, so it is extremely collaborative. It's about synthesizing the constraints, synthesizing the current research and the best of what we know, and collaborating with diverse groups of individuals from different subject matter expertise, so that we can come up with a concept that feels good for everyone. And it really is about synthesizing those constraints and bringing a human factors emphasis to ensure that we are creating an aspirational space that people would actually want to live in, you know, in the long term, and that doesn't feel like I don't know, that doesn't feel constricted or confined, and that would actually be somewhere that people could thrive.
Excellent, excellent. When I look at your portfolio beyond the Mars structures, you also you have this really fascinating paper in the International Conference on Human-Computer Interaction. It's entitled Preliminary Design of an Autonomous Medical Response Agent Interface Prototype for Long-Duration Spaceflight. Obviously, you know, once you get beyond the moon, it takes a while to get places, and aside from everything that you need to work on in regards to housing and keeping people alive on Mars, you got to keep them healthy. You've been involved in other health-related projects, like there's an interesting mobile app for CPAP therapy that I saw you were involved in. Talk a little bit about sort of what goes into what you think about in terms of, you know, if someone has a heart attack or gets a cold or whatever happens on the way to Mars. Talk a little about this project, if you would. Really fascinating stuff.
Definitely, definitely. So like you said earlier, I have a very mixed background. I started off in industrial design. Actually, I have a liberal arts degree before that, and then I shifted to architecture. My ideas kept getting bigger and bigger and bigger. And I also studied human-computer interaction. So for me, the core themes and the core topics that I work on and that I really invest myself in are the intersection of design and technology. So a lot of the projects the two projects that you've mentioned, right, the CPAP therapy and the autonomous medical response agent, are really about ensuring that we can provide technologies, provide autonomous systems, and I guess you could say services that can ensure that people, when they are en route to Mars or on Mars, actually have the information and the capabilities to self-treat, self-diagnose, and rehabilitate themselves should there be an emergency in transit or on the surface of Mars. The real challenge there is that current spaceflight operations work with basically real-time interaction with mission control. So you always have somebody watching what you're doing, telling you what to be doing, and you always have that connection back to home in case something goes wrong. So you could speak to your flight surgeon, your medical doctor on the ground in the case of an emergency or in the case of something, you know, or if you're feeling ill, for example. But en route to Mars, you're going to have bandwidth restrictions, you're going to have communications latencies, and even blackout periods where you're not going to be able to call back home. You're not going to be able to speak to ground at all. So one of the big goals and aspirations of NASA and other spaceflight agencies is to ensure that we can give the astronauts, we can give the crew as much information as possible, and provide these countermeasures so that they're not in a position where they don't know how to self-treat, they don't know how to handle a medical emergency. And it's a big problem, you know, is ensuring that they have everything that they need en route to Mars, and on their way back, of course, because they're not going to have, they're not going to be able to call back on whenever they wish.
Really neat. Really neat. Makes me think of Prometheus.
Right.
But someone's got to design that. I guess it could be you. It should be you. Speaking, you mentioned bigger and bigger and bigger projects. One I love just reading about. I don't understand it, but I just have to mention it because it's probably the biggest of everything I've seen in your portfolio. But you have this fascinating project called Mapping the Human Brain, but it doesn't have to do with traditional technologies. It has to do with space stations and satellites. Listen, this is a little more science fiction-y, but take us down this road. This is a fascinating concept because we talk about, we've actually talked to some individuals in the past about sort of information in the cosmos and so forth, electromagnetic fields, whatnot. This struck me as sort of a really interesting interface between obviously the things we understand about the human brain, obviously things that we are learning about, what the universe is all about in terms of information flow. Talk about this project, if you would, to what the extent what you're allowed to talk about this one. This is really cool.
Yeah, definitely. This was actually a project that I did in graduate school, and it was intended to be, like you say, a kind of a speculative science fiction aspirational project where I introduced a space station in, I think it was geostationary orbit, and essentially the idea here was for there to be a kind of life-size replica of the neurological makeup of the human brain. So, and there's lots of applications that I could see this having, but essentially from my project was about implementing a space station with millions, possibly billions of microsatellites that could represent individual neurons, that could represent individual components of the human brain, and having a kind of real scale, real life-size replica of maybe not all, but certain parts of the neurological makeup of the human brain. I was seeing this as a kind of, I guess you could say, a receptacle for human intelligence, a kind of way of memorializing human intelligence or capturing human intelligence. And for it to be an evolving thing. So yeah, definitely a speculative concept, but one that that was very inspiring to me at the time, and kind of bridging between science fiction and art, right? But there was something very powerful to me about being able to contextualize this within a physical structure and having that be something that's seen, having that be something that people could actually look up to from Earth.
Really cool. Really cool. Coming back to space exploration architecture, obviously, a lot of what you mentioned earlier in terms of the 3D printing, the shielding, how we grow food. Are there any other interesting, obviously, once again, things you could talk about that are not, NASA secrets or whatever at this point, but any other interesting things that we don't normally think about when I'm watching my sci-fi movies or when Elon Musk is doing his thing on TV? Any interesting niches in terms of some of these designs that we might not, the average person like myself might not think about, but wow, these are things that we have to address before we get out there. Things like, contaminating a planet with microbes or trash in space, or whatever accompanies all this stuff that's headed out to Mars and beyond. Any interesting themes there that you could talk about?
What a great question. Well, our emphasis has shifted pretty radically to the moon.
Okay.
Which is conceived kind of as a stepping stone to Mars in any event. I really don't see it happening that we would get to Mars without the moon being a fully settled, developed base, really, and an international I guess you could say, settlement that to serve as a stepping stone and as the platform for future exploration to Mars. I think some of the leading topics and the most essential topics that I've been engaged in and that current research is really focused on is on resource extraction and creating a sustainable strategy for how we can not only create pressurized environments that, you know, that can sustain life and that would require oxygen, for example, but also for creating rocket fuel, so that we can not only go back and forth from Earth, but eventually get to Mars. So this is one of the key enablers, technology enablers for settling the moon, establishing a permanent presence on the moon, and also for going to Mars. In order to do that, one of the key resources that everybody is super interested in is water ice. Mm-hmm. So a few weeks ago, there was a big announcement from NASA that they had identified way more water ice beneath the surface of the moon than previously expected. And of course, we know that that's the case for Mars as well. So these long-term sustainable strategies are not only about creating and bringing infrastructure from Earth, but creating a kind of, I guess you could say, closed loop ecosystem where we can actually be manufacturing the materials that we need on the surface of the moon and on the surface of Mars. And that would be the strategy for kind of sustainable development and long-term development. So that's really the secret sauce, I think, for coming up with long-term and valuable strategies for settling and inhabiting the moon and Mars. In addition to that, of course, I think in the near term, not everything is going to be an ISRU, in situ resource utilization printed structure. We're certainly going to have modules that are pre-integrated hard shell modules, such as like the lunar module from the Apollo missions that are going to launch from Earth and land on the surface of the moon. Yeah, and how exactly the expansion of the initial lunar base happens is also an extremely interesting point to think about. Like a close analog that has been sort of proposed is Antarctica, where actually resource extraction is not allowed. But you can imagine how complicated it will be, and it is, for international partnerships to not only be solidified, but to ensure that there will be peaceful and I guess you could say diplomatic relationships on the surface of the moon, and in planning to just kind of establish these initial lunar settlements when we do, which is frankly quite soon. So these issues are extremely interesting and they're on the cutting edge. I don't think that there is a definitive answer to what the Artemis, like NASA's Artemis Accords, are necessarily going to yield when it comes to international relations. And it's a really interesting topic. And I really admire the people who are sort of leading the way in having these discussions internationally, because it's a challenging and very optimistic kind of prospect, right? That we're going to be working together similarly to the way that the ISS kind of came together to come up with partnerships and also joint initiatives for settlement on the moon.
Wonderful. It's the future now, however many decades. We have the search plus cities on the moon and Mars. Where does Melodie Yashar want to go next? Are you interested in floating cities in Venus, the moons of Saturn? What are, for somebody that creates the future from science fiction that I watch, what are your next sort of science fiction interests beyond Mars?
That's such a great question. You know, a lot of the work that I've been devoted to and that I apply myself to is not only for space, but also for how we can establish dual use technology initiatives that can also benefit Earth. So it's not so much about, for me at least, not right now, looking out further into space, although it would be really cool to come up with like a concept for how we can, I don't know, build up, like you said, on an asteroid or on the moons of Venus. But for me, the emphasis right now is about bringing value back to Earth and ensuring that these technologies that we're developing relative to construction on the moon and Mars can actually benefit us and kind of disrupt the construction industry here on Earth today.
Got it.
So a lot of that is going to be about creating sustainable strategies for materials use, creating sustainable strategies for how we think about civic infrastructure and the ways that cities kind of build if they're just developing, and coming up with a more ecological means of ensuring that we have closed loop systems for energy and for other resources that we use. And these are all essential things that we have to be thinking about for the moon and Mars too. So why not help ourselves now in the short term here on what's like affectionately termed as spaceship Earth, and also advance the future of what it's going to mean to inhabit these other planets in space.
Excellent points. You just stimulated one other question that was on my list, but thinking about a lot of these sorry if I'm going back to the aliens so but some of these series have this terraforming technology in it, which is another sci-fi-ish type technology on how one transforms whatever we'll call geoengineering or what have you. Obviously, that's a little maybe further out there, but any interesting one I want to sort of get your feeling of it. Is terraforming even something you think about for future projects, and then sort of, as you were saying, the dual use. Any interesting things on that front, if you do work in the area, that obviously we have a lot of environmental and geological issues here that potentially could be applicable for such technologies, or is this something that it's not on the drawing board right now for your firm?
I think it's extremely fascinating to think of these, I guess you could say, these global planetary concepts like terraforming. And it's a lot of fun. It's just not something that I've focused on specifically. Okay. My emphasis has really been on at the scale of the human body and at the scale of the building and what's in between that. So I try and think about designing for people within a cybernetic system. So the relationship of people and the technology interfaces that they work with and that in space would be keeping them alive, and then how exactly that would integrate within a structure and an environment that likewise, in a space vehicle would be keeping people alive. So that's really my focus. I try and keep it at the human scale. I also teach like you mentioned in the introduction, a course at Art Center called Life on the Moon, and really the approach that's taken when I teach that class is that the students either begin with an intervention at the scale of the human body and then work outwards to create an environment, or they start with a structure, some kind of pressurized membrane or pressurized, I guess you could say, environment, and then work inwards to the point where you're actually creating an intervention for the human body. So that's really the scope of what I've worked on and what my emphasis has tended to be. But terraforming is very cool, and it is fun to think about.
Just thought I'd throw it out there.
Yeah.
Melodie, obviously that you've had such a multifaceted career to date in academia, in government with NASA, and private industry. Take a little time, if you would, just to mention any mentors, influencers, co-workers that you can shout out to anybody, folks that have really been influential along with you with this journey. Take your time and mention anyone that you want to. And shout out who have been with you and sort of inspired and been alongside you as have been on this amazing journey.
Definitely. My first shout out would go to the search team and to our broader network of collaborators, consultants, subject matter experts that we have worked with throughout the years, and also to the people who have really been patrons to Search and who have sort of driven us to push our concepts forward, and who have enabled us to create things like the Mars Eyes Home, and to collaborate with ICON and with NASA Marshall. And the first and foremost patron that I want to shout out is Manzi Rahman, who is the head of NASA Centennial Challenges. She has been a very strong supporter of Search ever since we won in the phase 1 challenge of the 3D printed habitat competition. And she's been extremely generous and extremely gracious in connecting us with people in the industry and with researchers who are interested in our work. And we're very thankful for that. Beyond that, I want to give a shout out to everybody within NASA Ames in the Human Computer Interaction Group and Human Systems Integration. I learn from everybody in that lab every day, and it is a great culture and great community of people that I'm very thankful to be a part of. And yeah, I think those are the main ones.
Wonderful, wonderful. Melodie, really fascinating stuff you're doing, and really wishing you the best, and obviously you and your team moving forward in more of these projects and getting them off the ground. It's truly fascinating work, and this translation of sci-fi to sci-reality is, we need more folks like you thinking about this stuff, because it's the way we all create this better tomorrow. And for everybody that's going to be watching this episode or listening on the podcast, you've been hearing Melodie Yashar, designer, researcher, technologist, co-founder of Space Exploration Architecture, senior research associate, NASA Ames Research Center at the San Jose State University Research Foundation, and associate professor at UC Davis at the Center for Human Robotics and Vehicle Integration and Performance. Melodie, thank you for everything you're doing to create a better tomorrow. It's been really fascinating, and thank you so much for spending time with us today.
Thanks so much, Ira. This was really fun. I appreciate it.
Thank you.